This is one of those effects that seems simple on paper, yet I can't find a good tutorial for it, and I think we can put this off in geometry nodes. Basically, we're going to have a collection of objects animated along a path, and they will be going infinitely down that path. And also I'll show you how to rotate them randomly and how to set this up so that the radius of the curve at different points dictates how far out they go, and how you can get the tilt of the curve to control the scale as well. So yeah, let's just jump right into it. This is Blender 3.1 alpha, by the way, and all I have here is a collection, or rather I have a bunch of objects that are just my leaves, and I'm gonna go ahead and put them inside the new collection, which I will call leaves. So get all of these, drag them into this new collection, and we need this, and then outside of that collection I will spawn in our curve. So Shift A, Bezier curve. There it is. I'll go into my GeoNode setup. It might look a bit different from yours. Just make sure you have a geometry nodes editor open. Click new to add the geometry node, and at this point let me just see my leaves. All I would need to do is just instance on points, and to fetch the collection in here all I need to do is a collection info. There they are, and then I'll just plug instances in here. I will also do join geometry so I can see both my curve and the instances, and I'll plug in this curve as the points. Now currently, if I just had the original collection, you're going to see that they did spawn. We have two copies of them. If I move them around a little bit, we should be able to see them. There we go. However, it's spawning the entire collection at these 2 points of my curve, and to undo that I just need to do separate children, but also reset children. So by default, if I see in my collection everything is offset from the center of the world, and that's why I'm doing reset children. That's essentially what that does. Now however, it's spawning all of them at these 2 points, but I don't want that. What I want is a single one, so I'll click on pick instance, and then I'll need to drive a value for this, so a random value, because it's going to pick them from the order in which they are over here. Okay, what I mean by that is if over here, before I pass in this, I resample this curve based on the length, and this is the fine amount for now, and then if I just reduce the scale a little bit, you see that they're all coming in the same order, and that is the order of 0, 1, 2, 3, because this is how they're indexed inside this collection. So I need to offset that by plugging in a random value that is an integer between 0 and 3, because those are our 4 indexes, into the instance index. Now the randomized, I can do that a little bit better with a seed, and now they're completely random along our curve now. So this is most of the setup we needed. I will now again hide this original collection, and I will then just straighten out this line so that we can preview some more things with it. Just absolute grid snap over here, and I'll also do this for the handles because I want this to be a straight line right now. However, this didn't work well. There we go. Now they're in a straight line, more or less. So the first thing I'm going to do is I'm going to align them with my curve. So align Euler to vector. And to be more specific, if this is my curve, every curve has a normal that is pointing away from it and a tangent that is pointing in the direction of the curve. I'm going to align everything to the normal and then rotate the normal around the tangent. This is how we're going to get our random rotation around our curve. So let's do that. Go ahead and plug align vector to rotation. Grab your normal, plug that as the well, first off, we said we're going to rotate it, so vector rotate. So this is the axis, or rather the vector I want to rotate, and I want to rotate it on the tangent of the curve, like we said. And if I plug into the vector to align to, I want to align y, simply because my leaves I know are aligned so that y is going across their length. And over here, now I can change the angle. You can see we are rotating them around our curve. Now we want this value to be random, so what are we going to do then? I'm just going to get a random value, just like that. Now if this is from 0 to 2 pi, that will give me 360 degrees in radians. So this is all great. Now they're all rotated, but they're not really animated. If I play the time, nothing will happen. So let's talk about how to animate them, but maybe first I will push them away a little bit. They're sort of overstacking right now, so I'll go translate instances, just like that, and I'll move them on the Y because that's the axis that I aligned, and I will maybe make this a little bit bigger so we get more instances, just like that. And now let's talk a little bit about this random value. So it has an ID, right? And what is this ID? Well, the ID is actually a node, and by default it's as if it's plugged in here. Like this is the default value that is in here, that's why it's called ID. But you can think about the ID as another seed. So each one of these instances has its own unique ID, and that is what it is using to get this random value. But also you need to keep in mind that this ID is actually increased by 1 for every instance. So as we're going, this can be an ID of 0. Let me get my grease pencil, 0, and then the next one would be 1, and then 2, and then so on and so forth. So why is this important? Well, if I just add some value to this ID, then I'll be essentially shifting the random value over here along the length of my curve. And we can see that. Do you see that now the random value for the rotation is moving forward? You can see right here, for example, if I keep track of this object, you notice that it is as if it's moving forward, but in reality I'm just changing the position of the instance at that point of the curve. So that's an important distinction. Now I don't want them to also flip the way they are. They're just picking a random instance out of the collection, and to fix that I just need to use this ID drive to also drive the random value of the picker. So just like that. And now as I change this add value, we will see that they are now the same object as they are moving forward. Okay, another cool thing, I can just plug in the scene time into here. However, if I want to plug in the seconds, which is what I want to do, because I want this to be independent of the frame rate, which can change depending on what you want. To do that, I would need to first go through a math node in order to use a ceiling function. So the ceiling function just takes floats and makes them whole numbers, integers. And this is because the ID value is an integer, and it will get messed up if we use floats. So for example, if this is 0.5, it will just make it 1, just go up. So I'll add that here, and now if I press play, you see that they're moving, although extremely slowly. To fix that, we just have to use another math node, which will be set to multiply, and if I set this to something like 30, we should get a decent motion going. Now you can see they're animated on our curve. However, they are moving quite linearly, and that is because all I'm doing is I'm shifting this random value forward. But instead of doing that, what I can do is I can use a noise texture. Now the noise texture actually uses the position of the instances in 3D space to get me a random value. So if I set this to 4D W, and for the W I use this value, and then I pass this, 1 second, into this vector, but only through a math node so that I can boost the value of this factor, we're going to see that, well, first off, they're very shaky. I need to reduce the detail and the roughness to 0 and set the scale to something super low, like 0.1. And they're not really covering our whole curve. To fix that, because this is only a value from 0 to 1, and in radians that is not enough. So we will just increase this multiple value until we have a nice coverage here. Okay, that's good. Now we can see them moving, right? They're sort of moving along the length of the curve. However, you notice that points that are very close together, they stick together, they always stay together. That's because, like I said, the noise is based off of space. To fix that, before we actually plug in the W, you're gonna have another node right here, which will be a multiply node. And we need it to be in a high value, just to offset this W a little bit. And that's the same thing that will be driving the ID over here. And now you can see that things that stay together, that are close together, don't really stay together for long anymore. For example, over here, they're coming apart. If you increase this value even more, that will increase that difference even further. So now we have a lot of randomization, but that's only on the rotation. So let's talk about getting this on the diagonal, because they're currently in a cylinder. That's not good. I kind of want them to be moving in and out, like in this direction as well, so that we get more of a flowing motion. So in order to do that, instead of using a solid value here for the translate instances, I'm going to again use a random value. And for example, I will need to do a combine XYZ and have this drive the Y, because that's how they're aligned. And as I increase the Y, you can see now, sure, they're random. They're a bit too random because I need to connect the ID here as well. So get this ID, plug it here. Okay, so now the issue is that sure, they're random, but we're getting the same issue where things that are on the end will forever stay on the end, and points at the center will forever stay in the center. But I kind of want them to go all over the place, so again, instead of a random value, we'll just use a noise texture. Right, set this to 4D, and the W will be controlled again by this. We're really doing the same thing, zero roughness, zero detail. Again, a matte node, just so we can boost that. Pretty low value over here, something like 0.2. And I'll plug this into the Y. And of course, we need to boost this up a little bit. And now you will see them moving. However, they're really only moving like this. If I go into orthographic view, really only moving like this, because this value is only from 0 to 1, but I want to be able to also get negative values, so I can stretch into this area as well. And to do that, it's very simple. Just pass this through a subtract, from which I'll subtract 0.5. There we go. Of course, now I will need to boost up this a little bit more. And now my leaves, you can see them, they are going in and out as well. Yep, it's not that easy to see, but definitely from the front maybe you can see them a little better. They're also going, yeah, there we go, inside and out. So that's important. One more random thing we can do is we can also rotate them on their own axis. So if I get rotate instances, and for this one I will use a noise texture and an align Euler. So this time I'll use the color attribute, which means that I will need to pass this through a vector math in order to just subtract 0.5, because remember the color is in RGB, but we need it to be from RGB, which means 0 to 1, but we basically need it to be at the center, so minus 0.5 to 0.5, and that's what this gives us. Basically the end result is a vector that's pointing in a random direction, and what I'm going to use is this vector as the vector to align my instances with. Okay, once again, no detail and no roughness in this case, and a pretty low value here, something like 0.5. And now we will see, in fact I can just show you what this does exactly by changing the scale over here. See, we're rotating them on their own axis, right? So 0.5, and now we're getting a really fluttering motion. Basically these instances are now as random as they can get, right? This is what I was going for. Okay, so that's great, but one thing you might have already noticed is if I set the speed even lower to something like 10, suddenly things get very choppy. Because remember, these things are not really moving in space. I'm just changing the next instance to look like the last, or rather the last like the next one. It's a bit confusing at that point. But yeah, so in other words, to increase this, to reduce this choppiness over here, I would just need to increase the samples on my initial curve. So if I say something like 0.01, now things will move way smoother, but also way slower, because again I have more points. So the easiest way to do this, and I will admit this is sort of a choppy workaround, is to go into your instance collection, where it contains all the things you're instancing, and just add an empty. So the empty is sort of going to be like a dummy. See, the real issue is that I cannot just reduce the points using this selection, because then again I'd have less points, and again it would get choppy and would change the frame rate again. In order to not lose that instancing, that index, which is crucial, we're just going to hide some of these instances. What I mean by that is by making sure I have an empty here and naming it 0, it will always be at the start of my collection, and it will always be indexed 0. Which means that if I then take this value from 0 to 3 and I run it through a math node set to multiply, and then I use another random value which is again driven by the same ID, and I say that this is a boolean, this will output a value from 0 to 1. If I then multiply this, then what that means, and you can even see the empties over here, what that means is that whenever this value is set to a low value, then there's a higher probability to get the number 0, or rather to put the 0th index object, which is just this empty, essentially removing our objects from there. Okay, you can see now this controls the count of objects. However, you see that they're all the same. That's because the seed value of this and this needs to be different. So I'll just move that a little bit, and now we're back to our randomness, maybe even more. There we go. This is sort of the effect I was going for. Eevee seems to be blurring my screen because of the viewport denoising. There we go. That's a lot better, I think. So that's the effect we were going for. So now you can control the count from over here. And the maximum count is limited, though, to this amount, which is again dependent on the resample curve. So if you want an even higher maximum amount, just lower this number, but then you would also need to change the speed again. So just keep that in mind. But if you don't need any more points, then this is perfect for controlling the count. And you have a control for the speed, and everything is now smooth. I'll reduce these instances. I really do not need that many right now. So I'll go back to this situation, and I'll probably just mute this node, or I'll just set it to maximum so that it never really picks the 0th index. Although something I forgot, now that we have 5 indexes here, or 5 items here, the maximum index here increases with 1. Otherwise I wouldn't be getting all of the items in. So just like that. And in fact, this needs to be 1 as well, because this random value must not actually give us the 0th object. So yeah, definitely make sure this is the case. And if this is just 100, that would be all of the instances. They'll probably move too fast now, so I'll just reduce this back to 30, and we'll get to something sensible so that we can continue. Let me hide this collection again. Okay, so let's talk about the radius a little bit. So here I am actually controlling the radius of the effect, right? And that's pretty good. But I want to control that through my curve, because the curve already has a radius value at its points, which I can control from here or from just out S. I want the point in the middle, so I'll select these two. 1 second. I'll select these two, right click, subdivide. That will give me a middle point to play with. And then in order to actually use that radius, I need to capture it. So remember, capture attribute stores information inside the geometry. In this case, inside my instances. I will capture this radius and then have it driving this multiple here for the spread. So if I go to this point, Alt S, and spread it out, you will now see that my leaves, as they go to the middle, they sort of spread out, they fan out, while they're just joined at the start and end. At this point, it's important to note that the scale here does affect the translation in the future. So you see, as I increase the scale, this translation has a different effect now. Alright, so that's cool, but what if I also want to use my curve tilt? Because currently my curve tilt is not really being utilized. Now, currently the curve tilt will rotate my normals. Okay, and remember, I'm using the normals here to actually align my objects. And that kind of sucks, because I can no longer use my curve tilt for anything else, and these objects are already aligned randomly. So instead of using the normal, what I'm gonna do is I'm gonna pass this tangent through a vector math node. And this vector math node I will set to cross product. So I will take the cross product of the vector and a vector that is pointing up. So that would be a 1 on the Z, and then use that. So essentially nothing has changed. However, my tilt parameter no longer affects my objects. Okay, so I can just use that parameter for something else. But first, let me talk about this cross product. What did it actually do? Well, the cross product of two vectors, like imagine we're looking at two vectors from above, they're on a single plane, would give me a third vector that is perpendicular to them. So that would be a vector facing me right now in the 3D space. So when I did this little trick over here, I basically got a new vector that was perpendicular to the tangent one. And remember, since the tangent vector is already going towards the end of the curve, a perpendicular vector to it would just be one that is basically a normal vector, although it would mostly be random. Alright, so I hope that explains that. So to actually utilize our tilt, I will go here between the translate and rotate instances, and I will go scale instances. And in order to actually be able to use the tilt here, I will need to capture it as an attribute again. Go ahead and grab the curve tilt, pass that into here, and they're all gone, because by default the tilt is equal to 0. But then I can just press Ctrl T to increase the tilt, and you can now see they are coming in. I think I have to move up. Yeah, there we go. Now they're coming in. So essentially, at the start they have a scale of 0, at the end 0, and at the middle they have some scale. So now I can control how far they go with my radius, Alt S, and I can control their scale with Ctrl T for the tilt. So that's a pretty good way to utilize the tilt in this case. And if I just press E, I can just continue this on. However, they have nothing here. I need to scale them, give them some tilt, give them some radius, quite a bit of radius. There we go. And this is a pretty interesting effect, I think, yeah. There we go. So definitely play around with this. One more thing, if your animation or the curve looks choppy, that might be because you don't have enough resolution. So for example, if you have really sharp angles here, you're gonna start to notice these defects. Just bump up the resolution preview. Don't be afraid to really crank this up. It doesn't really affect performance that much, I think, because this is just the way Blender previews curves, so that's important. And one more note, if you want to animate curves, it's very simple. Just go to Preferences, Add-ons, and enable the Anim All add-on. It comes default in Blender. After which, if you're in edit mode and select any point of your curve, you can just go into the Animate tool on the right side and select what you want to key, point, radius, tilt, and then just insert keyframe if you have any experience with animation, that is. This should be pretty easy. And of course, I am pretty sure at least that you can also just draw curves. So if you're in edit mode, you can just go to this button and you should be able to just draw another one of these. And yeah, they also animate, which is pretty cool. However, I have not set up the radius for this one, that's why they're all flattened here. And you can just go ham at this point. I don't know what else to tell you, I guess this was all of it. And of course, the finishing touch would be outputting all of this information, like the count over here, into your modifiers tab. So for example, if I take my group input and I just, oh well, Blender crashed. So I guess that's it for this tutorial. Thanks for watching. Subscribe for more, and leave a like, rate 5 stars, go ahead and retweet, ratio. Bye.